Hey everyone, good afternoon and Assalamualaikum. So, in this video, I will explain the Reynolds Transport Theorem, RTT. RTT is a crucial concept in fluid mechanics. This theorem helps us analyze fluid motion by connecting two perspectives. First, the system approach, and the second, control volume approach. Okay, so let's take let's start with the difference between the system approach and the control volume approach. So this the A picture figure A is about system approach. So think of a spray can of deodorant. If we follow the particle as they move and deform, we are using the system approach. And this picture of B, this using control volume approach because imagine a fixed portion inside the spray, then where mass enter and exit through its boundary. So this is control volume approach. So first, uh, about this diagram, we can calculate and then we can get a formula. Using this diagram, we will have this formula. Okay. Then to that, from this formula, we can subtract the first equation from the second, so we can get this formula. After that, taking the limit as change of t to 0, so after we derive, we get this formula. Or also can get this formula. Since this, so we derive and calculate, we get RTT fixed CV. For the left hand side, dB system over dt is the total rate of change of an extensive property. Example, mass, momentum, or energy in the system. Okay, for this right hand side, d over dt integrate CV PV dV. That's the rate of change of D inside the control volume due to accumulation or depletion over time. B, the intensive property per unit mass. For example, density for mass flow. For this second term on the right hand side, PBV dot NDA. That's the net flow of B across the control surface. Vn, V dot n is the velocity component perpendicular to the control surface, determine how much property is leaving or entering. So that's how we can to use RTT fixed CV. Then this is alternate RTT fixed CV. This non-fixed CV. This formula. And then this RTT steady flow. Okay. So this relative velocity, the velocity VR, relative velocity is the velocity of fluid as seen from control surface that may be moving. Then this is V absolute, the velocity of the fluid in the fixed reference frame. and VCS, V control, the movement of the control surface itself. Okay. Then for this formula, it define inlet and outlet. Okay, for inlet and outlet formula based on this diagram. This is an example control volume. So for inlet and outlet, from this formula, inlet is the flow rate of fluid entering the control volume. Then this is outlet, the combined flow rate leaving the two outlets. Okay. After we derive, so this is the last approximate activity for well-defined inlet and outlet formula. So we can use this formula to find inlet and outlet. So that's all. Thank you.